Instead of having to go into TradingView and manually figure out where to place the Fibonacci sequence for potential entries, wouldn't it be way better to automate this instead? In this coding video, I will code the auto Fibonacci where I leverage Python and Yahoo Finance data to automate retracement levels to see key price levels for stocks, cryptos, and ETFs for potential reversals. As a bonus, the complete Jupyter Notebook is available in the blog section of intrendias.com for completely free. Please leave a like and subscribe if you find the video helpful and the Jupyter Notebook helpful as well. Now, back to the video. First, let's review the Fibonacci Retracement tool. The Fibonacci Retracement identifies potential levels of support and resistance on a price chart. We want the start of the fib based on a clear trend. To know where to place the min and max or 0 and 1 of the fib, we can use the William Fractals, which highlights potential reverse points on a price chart, showcasing where to start our fib. Decrease the window period of the fractals to 10 to eliminate many false signals. Now start your fib at the min fractal and end the fib so that the 0 line is touching the highest high. Therefore, this video will calculate the William fractals to then figure out the retracement levels. So let's get to coding. First, we import some libraries that we need, like Yahoo Finance, to fetch the stock, crypto, ETF data that we want to search. The arguments for our get stock data function are symbol, start and end date. The symbol will be a string for like AAPL for Apple. In this example, I fetch Apple stock data for open, close, high, low, close adjusted, and volume traded in a 1-day interval. Next, we will calculate the William fractals to identify potential reversals. A bar is considered a potential fractal high if the high of that bar is greater than the highs of the bars immediately before and after it. A bar is considered a potential fractal low if the low of that bar is less than the lows of the bars immediately before and after it. This custom function now returns our data frame plus the fractal high and low columns we just created. Next, we can visualize the fractal high and low along with the Apple stock high and lows to see if our function is working correctly. We can directly call the columns from the data frame into plt.plot and use scatter for the fractals to overlay on the stock price. And our fractals will look pretty good. Next, we can create another custom function for the Fibonacci retracement. I am using a tail of 120 where we are considering the last 4 months worth of data. If the interval argument is in the minute time frame, then we would be considering the last 120 minutes instead of the last 120 days. I found 4 months to work well on the day chart. However, you can customize this to your needs. Next, we calculate each retracement level, which are the 0.236, 0.382, 0.5, 0.618, and finally 0.786. To test and see what the retracement levels look, we can do a for loop and print the new dictionary results. Finally, let's visualize the Fibonacci sequence on the stock's close price. I went back and included the 0 and 1 line in my Fibonacci dictionary. Then I used matplotlib again, the scatter for the fractals, and the plot for the close price. I can do a for loop to plot a line for each retracement level and store a dynamic label using fstring. There we go. We automated the Fibonacci sequence for Apple stock. We can also search for other stocks like Tesla or even cryptos like Bitcoin. I hope you enjoyed this coding video on automating the Fibonacci retracement. The complete Jupyter Notebook is available on my website at intrendias.com. In the blog section, sign up for the Intrendias Essentials, the free and always free tier. Please like and subscribe if you enjoy the video and to not miss out on more coding tutorials and stock coverage. I will see you guys in the next one.